Let's try and understand Kepler's law of areas. To begin with, let us start it with this sector. In this sector, this is vector r. The ellipse in which our planet is moving is huge. And we know whenever it's a huge, the arc becomes straight. So we assume this to be a triangle. Alright, so just imagine that this chip, I've brought it here. The sector which is there, I brought it over here. So this is A, this is BC, this is BC. Alright, so this is vector R and this is vector V del T. Why V del T? Because we know vector V is equal to distance over difference in time. Now why difference in time? At 10 minutes it comes here and then at 15 minutes it goes there. So del T is what? 5 minutes. So that is what is del T. So V del T gives us S. This is vector V del T and this is vector R. Now in area of triangle by vector method we have seen that area of triangle is half into cross product of adjacent sides. Cross product of adjacent sides. Now this side is vector V del T. So R cross V del T. Alright. Now what I do is I put this del T below A. So it becomes del vector A upon del T is equal to half vector R cross vector V. Alright. Now again, linear momentum vector P is equal to M vector V. So vector V is equal to vector P over M. So we got a new formula for vector V. So we can jolly well substitute over here. So on substitution we get this equation. Del A over del T is equal to half vector R cross vector P over M. Now again we also know R cross P is angular momentum. So del A over del T is equal to, and symbol for angular momentum is L. So vector L upon 2 into M. Alright. Now M we know is constant. Mass is constant. And angular momentum, we know that angular momentum remains constant if no external torque tau is applied. And there is no external torque in universe. Therefore, L remains constant. So this is constant and this is constant. So del L over 2M is also constant. So anywhere in the ellipse, the aerial velocity would be constant throughout. Any sector you choose. Alright. Now let's understand law of orbit. In case of law of orbit, all planets move in elliptical orbits around Sun with Sun at one of its foci of ellipse. Now this is a very simple law, but why did I put in? I put in because I wanted to also put in some more informations about ellipse. Like in JEE, it could be correlated with some mathematical aspect also of ellipse. So I just try to put in some mathematical aspects like the equation of ellipse is x square over a square plus y square over b square, where we are aware that a is semi-major axis and b is semi-minor axis and x and y are the variables, is equal to 1. Then area of ellipse is equal to pi AB. Again, A and B has the same significance. Now for A greater than B, as it is here, since the ellipse is lying on x-axis, so it is A greater than B. The formula is B square is equal to A square 1 minus E square. Now what is E square? E square is eccentricity. Eccentricity is C over A. What is C? A, we know what A is. What is C? C is distance of foci from center. Distance of foci from center. Alright, so that is what is E. So, and if B is greater than A, if we say B greater than A, that means this ellipse is lying on y-axis. Alright, then in that case, the equation would be A square is equal to B square 1 minus E square. All right. Then again, foci, equation for foci, suppose if you have two foci, equation of foci is for A greater than B plus minus AE comma 0, and if B greater than A, it is 0 plus minus BE. Alright, so just a rough idea about ellipse. Be prepared for any numericals. Alright,